Dopo questa introduzione adesso incominciamo ad affrontare però il problema della sostenibilità e quindi parlare di soluzioni e innovazioni tecnologiche più diciamo specificamente verso la sostenibilità. Quindi chiamerei a parlare il prossimo speaker, il dottor Martin Richter del DNV. Il dottor Richter è un ship type expert per quanto concerne gli yacht e quindi diciamo, focalizziamo adesso l'attenzione in particolare sulla nautica da diporto e sentiremo cosa si può fare in effetti per diciamo, dare corpo a questo concetto di sostenibilità nel campo appunto della nautica da diporto. Dottor Richter, prego.
Thank you very much for the introduction, and yeah, as you have probably noted, I'm not Italian, so please excuse that I will give my presentation in English. I hope you can understand nevertheless. So you just saw a video of what we are doing at DNV. The video itself was not related to yachting, more to the cruise shipping sector, where we are also quite active. But yachting is also a field where we are quite heavily engaged. So just go one slide back. Yeah, topic of my presentation today is sustainable yachting. What does it mean and what can we do? So the term sustainability is nowadays used quite frequently. It covers a lot of different aspects, mainly as defined by the United Nations in the 17 Sustainable Development Goals. In the maritime industry, most people which are talking about sustainability are referring to goal number 13, which is climate action, and more specifically to reduction of greenhouse gas emissions. So how can yachting become more sustainable, or how can emissions be reduced in the end? So this is a graph which we developed within DNV. So in general, there are two main pillars in order to achieve the net zero goal in 2050. The first one is emission reduction by reducing energy consumption, which you can see is also quite a significant step. And the second one, of course, is emission reduction by use of alternative carbon-neutral fuels, including alternative propulsion. And reducing energy consumption in operation is not only essential for sustainability, but also in order to compensate the increased cost which you may have when you're using alternative fuels. And it is a low-risk measure with high return of investment. So starting with a yacht life cycle, or life cycle of more or less every ship, there are three major phases, starting with the engineering and the construction, followed by the operational phase, including refit or rebuild, and last but not least also the recycling of the vessel. And each of these phases has an impact on sustainability. And when we are talking about yacht, of course, you always have to have the yacht-specific operating profile in mind, which differs very much from any other ship type. So CYBAS, the Super Yacht Builders Association, recently announced a study which they did, and that came to the result that 60% of the time a yacht usually is berthed in port, 30% it is at anchor, and only 10% it is sailing, and a fraction of that, of course, only at maximum speed, so mainly it's cruising speed. So when we are trying to reduce energy consumption with this operating profile in mind, you need to focus not only on propulsion, but also in reducing the hotel load. And what we can also say is that the starting point for the yachting is even better than for most of the other ship types, because yachts are traveling much less compared to other vessels, and they are already using usually marine diesel oil or marine gas oil instead of heavy fuel oil, which is used by the merchant shipping. But still, there are a lot of actions or options possible to reduce energy and then also reduce emissions. So now there will be a few slides with a lot of text because I asked a few colleagues to brainstorm a little bit what options they see to reduce the emissions or to improve the sustainability. First one, of course, it's maybe not coming to mind at the beginning, is the selection of the shipyard. So when an owner is negotiating a new vessel, of course, you can already ask the shipyard, how do you produce your energy? Do you have solar panels on the shed to cover your energy consumption or something else? So it's starting already when selecting your partners. And the following ones, some are easy catches or low-hanging fruits, as we say sometimes, because we have to take in mind that the decarbonization or the switch from fossil fuels to carbon-neutral fuels will take longer than we probably all hope for. So then when we are discussing a vessel itself, you need to evaluate what range is really required for a yacht, what speed is really needed, because this has a big impact on the tank capacity. And you can either reduce the tank size if you can reduce speed or range, or if you go for alternative fuels, which usually have a lower energy density than diesel, you can compensate to a certain extent the additional amount of tank capacity you need for using ammonia, methanol, hydrogen, or whatever. And when we look at these yachts, they hardly need the range and the speed they are built for. So it's educating the customer as well in the beginning. So you really need to provide options or make them thinking about what they really need for the operation of the yacht. So maybe they can accept a slightly reduced speed, or they can accept a slightly reduced range. Okay. So then, of course, hull optimization should not be done for the maximum contracted speed, but for the cruising speed, because otherwise it does not really make sense if you design or optimize the hull for sometimes 20, 21 knots when the vessel is only sailing with 12 to 14 knots probably most of the time. Then optimization of the propeller, which does not necessarily have an impact on the emissions, but it has an impact on the underwater noise the vessel is producing. And it's also important to have the sea life in mind, so reducing underwater emissions is also a big topic which needs to be considered in order to achieve more sustainability also in yachting. Okay. Then reduction of hull resistance through suitable anti-fouling system, you already mentioned them. Some vessels, it's mainly in the cruise shipping, they're also using air lubrication systems. Maybe that's not that relevant for the yachting because they are not sailing that often. But to go for a good anti-fouling system, of course it needs to reduce the resistance of the hull, but of course the paint also needs to be environmentally sustainable when you apply it. So it's not only the vessel which you need to have in mind, it's also the paint itself which you apply. And of course once the vessel in operation, especially when these yachts are often in port for such a long time, it's quite important to clean the hull regularly and to bring a new anti-fouling paint on the hull. Then evaluation of optimal number and size of generators so that you are more flexible with maybe a higher number of generators but smaller. Then you can run the generators at the optimum load. Or what is probably already standard in this time is installation of an exhaust gas treatment system like an SCR unit. SCR means selective catalytic reduction, and it is in order to comply with IMO Tier 3 requirements, and it is to reduce the nitrogen oxides, so the NOx reduction. So within DNV we have several class notations which you may apply, like a silent notation for underwater noise, and some you have to apply if you have a certain equipment on board. So if you have an SCR unit installed on the vessel, you need to go for this notation so that it is verified and approved from classification point of view as well. Then leaving the propulsion a little bit is the selection of material. This is relevant at the beginning of the vessel's life, but also at the end. You should try to go for organically produced or recycled materials, such as recycled steel or aluminum, certified teak or alternative to teak. And you also need to look to sustainable ways for dismantling, safe disposal of hazardous materials. So every yacht above 500 gross tons needs to comply with the EU ship recycling regulation. So that means that these yachts need to have an inventory of hazardous materials, IHM, and they also need to have a ship recycling plan. Then, also having the operating profile in mind, reduction of hotel load through selection of smart system and components is quite important. You could go for a smart HVAC system, so these yachts are often more or less empty or only with crew on board in the port. So is it really needed to cool down the entire vessel without any guest? Of course, you need to take care of all the artwork which is on board that's mainly relevant for humidity. But if you could go maybe 1 or 2 degrees up, that would reduce your energy consumption quite significantly. So a smart HVAC system is quite essential to reduce your consumption. LED lighting is another topic. I think it is more or less standard, not only in the maritime industry, also in the apartments, in the hotels. And what you also need to do, these yachts are usually running for 30, 40 years. You hardly see a yacht being dismantled. So, of course, you also need to regularly review if there are new systems available on the market. So whenever you plan a shipyard period, could you replace outdated systems by more energy-saving systems or components, if it makes sense, of course. Then what you could do is consideration of dual fuel engines. If it's not that mature, which way you want to go, you could go for dual fuel engines or to an arrangement which is already ready to be changed for the use of low flash point fuels as at a later stage. It's not only the engine itself, it's also a lot of pipe works and coffer dumps which you need if you switch, and you need to have the space in the end if you try to modify at a later stage. Or what you can use now as a first step is the use of HVO. HVO is hydrotreated vegetable oil. It's a type of diesel oil which is produced from waste, primarily residue oils or fats, such as used cooking oil. And so you do not need any fossil resources to produce these oils because they are available. And there are several shipyards which already tested and confirmed that it's possible to run the vessel's engines with HVO. So then you need to consider diesel electric or hybrid electric propulsion with batteries, maybe also optional solar panels. You could either do this to cover the hotel load. You can do this for peak shaving, then you can go for smaller generators. Or you can also use this for emission-free operation in sensitive areas, or you don't have any noise, no vibration, no exhaust. So you could either use it if you're lying in a bay at anchor, or if you want a silent operation at night with guests on board. So that's always a possibility. Fully electric, I think it's mainly relevant for tenders and toys you put on these yachts. I don't see a fully electric mega yacht at the moment. It may come, but it's not foreseen. But of course, you should not only have the operation in mind, also need to consider where is the energy coming from in the end when you recharge your batteries. So if you use fossil fuel to recharge your batteries, you do not gain that much if you look at the full life cycle. The same is with electrical shore power connections for use of shore power in the marina. Again, you need to be aware where the energy is coming from when you're using the shore power. And last but not least, the most challenging part, of course, is if you consider alternative fuels and propulsion as a main means of propulsion for the vessel. So the conventional propulsion system of a vessel consists of engine, drive shaft, and propeller. That's the standard, of course, for diesel mechanic arrangement. And there are several modifications possible to this system. Of course, you can change the fuel, hydrogen, ammonia, methanol as an example. You could also change the energy source for propulsion. You could use the wind, you could use a fuel cell, or you can also use an alternative propulsion like sails, dyno-rig, or wing sails. In the earlier sessions, we heard a lot about sailing yachts already. So sailing, of course, is an option to reduce the emission during operation, but of course, it's a quite specific niche of the yacht market. The customer needs to like sailing. You have much less volume compared to a similar sized motor yacht. You have much more motion in the vessel, more heeling, so people can get seasick more easily. So what we see is that the sailing yacht market is picking up. There are more sailing yachts being discussed and ordered. Was I think German Freers who mentioned 85-meter projects this morning, so they're also quite large sailing yachts. But what you also saw yesterday from Super Yacht Times, compared to the number of motor yachts in new building and construction, it's quite a small number on new sailing yacht projects. We also see some hybrid yachts. It's looked like a motor yacht, but with a wing sail or a dyno-rig installed as well. But again, I think that will remain a niche market, so it will not be sufficient to achieve the sustainability goals. So if you want to do something with motor yachts, you have several fuels or fuel options which you could consider. This is more or less an overview which we provided in 2022. So as you can see, marine gas, oil, diesel oil is in general quite a good fuel apart from the green credential. So of course, if you compare new alternative fuels with diesel, it's always quite challenging because it's a well-known technology, it's easy to handle, so it's challenging to get a new fuel which is similar or even better than diesel. The table also includes LNG. I think it's just a bridging technology, not really that relevant for the yachts. But what it demonstrates is that it is really a complex picture. There's not only one fuel which will be the fuel of the future. There will be several options depending on the vessel type, size, operating profile. And for the yachting, you always need to have the specialities in mind. The fuel needs to be available. Usually the yachts do not have a fixed schedule or route, so they are operating remotely wherever they want to go. So it needs to be ensured that they can get the fuel when they need it. And usually these owners, they do not want to hear that they are restricted to operate. When they buy a yacht, they expect that they can go everywhere they want, probably excluding the polar regions because there are several other requirements. Then bunkering locations need to be clear. You may have some boil-off gases which you do not like to see, but if you are 90% not sailing, especially for LNG where you have the methane slip, but also for hydrogen, due to the small size of the molecule, you can have some hydrogen slip, which you need to consider. I think the manufacturers are working on that, but it's still existing. Then are you allowed to access the marinas with these fuels, or can you get fuel inside the marinas, or do you need to go to a certain area where you can bunker? Then, as already said, lower energy density, so you need more space or bigger tanks in the end, so that makes your vessel bigger unless you reduce speed or range. And it has an impact on the design. Of course, if you put wing sails on it, it's clear, but also if you go for methanol or hydrogen, you need vent funnels for the ventilation, and these needs to be 10 to 50 meters away from other openings. So it's usually quite a high funnel on top of the vessel. So this is a look into the crystal ball, how it may look like in 2035, so a little more than 10 years. We do see that the availability becomes better for methanol, bio-e-fuels, hydrogen and ammonia, but of course it very much depends on the demand. So for example, Maersk ordered a lot of container ships with methanol. Of course you have much more demand for this fuel if nobody else is using that. The maturity of the technology will also improve. And according to this, we at the moment would foresee that methanol is the fuel which will probably be used the most in the yachting in the foreseeable future, so short or midterm. Bio-e-fuels, also very good, but of course they are quite expensive. So that of course is a downside. But that's only a guess from our side, so it's not written in stone. But yeah, you always have downsides. Ammonia is poisoned, hydrogen is explosive, methanol is still a low flash point fuel, so you need to compensate some things compared to diesel. Then also the regulatory landscape is a bit complex. The light blue one is what we have published as a classification society. And the right side, the dark blue and mid blue and gray, is what is happening on IMO level. And you still see that there are some regulations in the making, mainly at IMO. So you just have guidelines or interim guidelines. You always need to agree with class and flag what can be accepted to compensate the additional risk you may have with this fuel you have in mind. Sometimes you need to go to alternative design and arrangement, which is quite extensive process. But with these guidelines coming more and more from the IMO, you get at least a starting point, and it makes it a little bit easier to get to a solution in the end. So what are the driving factors? Yesterday we heard the new generation of owners, the younger owners. Yes, to some extent probably that might be true, but what we see that it is not sufficient yet. So there are still a lot of owners trying to go for a conventional diesel mechanic yacht. Regulations may speed up the process. I mentioned a few EDI, EXI, CII, ETS, which usually all have to do with emissions. MRV, DCS is also data collecting, IHM, hazardous materials. But the thing is that the vast majority of these regulations are not really applicable to the majority of yachts, because they are kicking in if you have probably a 5,000 GT yacht, then they are applicable, but that's only the upper end of the market. So at the moment it does not have such a big impact, the regulation, apart from IHM probably, which you need to comply with. But it may change, of course. So IMO is reconsidering the limits, I think, in 2026. So it may happen that they will go down to 500 GT and also including yacht, and then of course then it's a completely different situation. But what you can always tell your customer is that there's an enhanced comfort level if you can have silent operation. Financial benefits in operation, of course, if you reduce your fuel consumption, you gain some money. If you go for silent notation, you can have reduced port fees, probably in Canada. I think Vancouver has a credit scheme for this. Then I call it future proofing, including higher resale value. So if you buy or build a traditional powered yacht now and you want to resell in 10 or 20 years, you do not know yet if you will still find a buyer, or you will probably get less money back because they need to convert to these new fuels in the end. And if you already go now for some green technology, you can ensure that you still have the possibility for unlimited cruising grounds. So there are some areas, Norwegian fjords, that limit the emissions in the fjords. So if you want to go in these nice areas, it's always better if you do something to become sustainable. Some have business reasons. There are some owners which are in the energy sector, involved in battery production, hydrogen. They are usually quite keen, but also not to underestimate is the public perception. There have been some protests in the Mediterranean, but also in Germany, claiming that it is just a small industry for ultra-rich people, and then the public said is, why are these people doing not more to become more sustainable? So in order to get a better picture of yachting, it would also make sense to consider more green solutions. So key takeaways from my presentation is, compared to the past, the future will be more complex. There will not be just one fuel, there will be more. Required energy will be more expensive, but you can compensate to a certain extent if you reduce your energy demand. regulation will most probably also guide yachting more towards an energy transition in the future, and increased collaboration is needed, particularly also in yachting. So there's still time at the moment to take action and to take an active role in the development of yacht-specific requirements, because they are special compared to other vessel types. Because if the industry is not doing this, they may probably be regulated by IMO, which not necessarily have the yacht specialties in mind. So as a conclusion, there are several options available to reduce energy or to go to more sustainable fuels. It is complex, and in order to achieve the climate goals which are from the UN, we need to consider all decarbonization solutions which are on the market. Thank you very much.